In this video, I am going to solve this second order constant coefficient homogeneous differential equation. In general, the structure of this type of differential equations is this: a y double prime plus by prime plus cy is equal to 0, where a, b, c are real numbers. And here, this is what my differential equation is: y double prime minus 8y prime plus 15y is equal to 0, with an initial condition of y of 0 is 2 and y prime of 0 is 4. Now, this type of differential equations, the general solution or the solution is of the form e to the power rt. Okay, that's the assumption we make. And if that is the case, y prime is gonna be r times e to the power rt, and y double prime is gonna be r square times e to the power rt. R is a number that has to be determined. So if I plug in these values, this and this into this equation, I should get r square e to the power rt minus 8 times r e to the power rt plus 15 times e to the power rt is equal to 0. If I factor out e to the power rt, is going to be r square minus 8r plus 15 is equal to 0. Since e to the power rt is not equal to 0, then it must be the case this is equal to 0, and that could be factored: r square minus 3r minus 5r plus 15 is equal to 0. If I factor out r, this is going to give me r minus 3. Then I could factor out negative 5. That's going to give me r minus 3. That is equal to 0. So if I factor out r minus 3, then I'm going to be left with r minus 5 is equal to 0. So that tells me either r minus 3 is equal to 0, in that case r is equal to 3, or r minus 5 is equal to 0, in that case r is equal to 5. Now I can go ahead and find those two solutions, so which are going to be y1 is equal to e to the power rt, means 3t, and y2 is going to be e to the power 5t. All right. So now the solution to this differential equation is going to be of the form y of t is equal to c1 times e to the power 3t plus c2 times e to the power 5t. Okay. Now, what is c1 and c2? Those values could be found from the initial conditions. Y of 0 is equal to 2. So I'm going to have y of 0 is equal to c1 times e to the power 0, which is 1, plus c2 times e to the power 0, because t is 0, right, is equal to 2. So this is one condition. And we know y prime of 0 is equal to 4. Okay. So if I take the derivative of it, this is what I get. Now, let's go ahead and solve this system of equations. So y prime of 0 is going to give me 3c1 plus 5c2 is equal to 4. Remember, I took the derivative of y of t and then plugged in t equal to 0. This is what I get. So from the first equation, I can solve for c2. c2 is equal to 2 minus c1, and then take this value and plug it into the second equation. I'm using the substitution method. So 3c1 plus 5 times c2, but it's going to be 2 minus c1, because c2 is equal to 2 minus c1, that is equal to 4. If I simplify it, I get 3c1 plus 10 minus 5c1 is equal to 4, or negative 2c1 is equal to negative 6. I subtract 10 from both sides, or c1 is equal to 3. If C1 is equal to 3, then C2 is going to be 2 minus C1, or 2 minus 3 is equal to negative 1. So C2 is equal to negative 1. So my general solution is going to be y of t is equal to C1 e to the power 3t. So 3 e to the power 3t minus e to the power 5t. So that should be my solution to this differential equation. I hope that this discussion was helpful. Thank you very much.